Hi everyone, today we're going to be watching this video together. It is what is a pressure transducer. This is the device that we're going to be using to measure the pressure of the water around the float, and then we're going to use that pressure to calculate the depth of the water around the float, the depth of water the float's at. All right, let's do this thing. So our pressure transducer looks something like this, and basically what's happening is it reads pressure on this end of the transducer. Ours looks just like this. And this is where you're going to do the reading. So the rest of this will be inside the float, and we'll just drill a hole and stick this one end out into the water. It can be the top or the bottom, and you can account for its position in the code wherever you put it on your float. And basically when there's pressure here, it's going to read the pressure on this side and then send the signal back to the Arduino using these 3 wires. We'll talk more about how that works in just a second. But as the pressure increases, the signal changes to the transducer. This is a strange gauge transducer. Inside this transducer, this is the kind we have as well, are these little electrical devices. And what you do is you run 5 volts or some voltage here. We're going to do 5 volts. Those electrons flow through all these tiny little wires back and forth. And this thing is really small, so these wires are really thin. And they're made with a very special combination of metals that whenever the wire gets stretched even a little bit, it changes its resistance by a lot. So as the electrons flow through here, if there's no strain on it, they flow through really easily and they don't lose hardly any energy, so they come out roughly 5 volt electrons on this other side after passing through all these little bitty tiny back and forths. If the gauge gets strained and twisted or stretched, now this change in the length of the wire and the thickness of the wire changes its resistance. It either makes it less resistive or more resistive depending on what materials were chosen. And that's going to change the electrons over here. So instead of being 5 volt electrons on this side, maybe now there are 3 volt electrons or 2 volt electrons or 1 volt electron. And just like a potentiometer, when you turn it, you're forcing the electrons to go farther through that resistive loop, which means they're losing more and more energy, more and more voltage as they go through that. And you can tell where the knob is based on how much energy electrons lost. This is the same way. By how far this thing stretches is going to decrease the voltage of the electrons or increase depending on the materials. And you're going to end up with this really cool way of measuring how much stress is on something. To use these in a pressure transducer, they're actually seated inside of the transducer. It's just kind of a front-on view looking at it kind of in that direction. Inside here there's this diaphragm, and then there's these 2 pressure transducers on either side. And this dark blue circle is this sort of plunger here. So, and here's the diaphragm. So the water can flow in here and it's like a flexible rubber diaphragm. As pressure increases here, it pushes that diaphragm to the right here, which pushes the plunger to the right, which stretches and bends these two devices here, which changes the voltage going through them, which is really kind of cool. And even small twists and movement will create a big change in resistance, which means you can now measure how much pressure it has. There's a few different types of these. We have the millivolt, the cheapest ones. They're about $6 for this thing. So really fairly inexpensive for the stuff we buy. You can buy more expensive ones that are better about working around other devices. These aren't great around lots of motors. Their low voltage signal means that they can be interfered with by nearby motors and stuff. So as you're placing this in your float, you may want to think about putting this somewhere away from the motor so that it can't have its signal interfered with. And I think that's pretty much it. That's how a pressure transducer works. They're super simple. We'll next talk about the programming of pressure transducer. Thanks for watching.